My name's George, this is Max, and we want to talk to you today about how we're using language models to improve the way we do search evaluation. Before we go into some of the technical details, I just want to lay a bit of context around why it is we're doing this work. When it comes to search, making improvements is very much an incremental process. Ideally, you make a change, you measure some performance improvement. Sometimes things go up, sometimes things go down, but generally we want to see that line going up and to the right. But what's most important is that we can actually quantify these changes. And that means both agreeing on which metrics define performance and also having a valid way of measuring that performance change. And the way that's usually done is through this common cycle. You start with an idea, something you want to improve, you make a change, and then you kind of want to get those changes in front of your customers. And that usually takes the form of an A/B test. Once you've run your A/B test, you can start to evaluate the data that comes out of it. And if you've had a positive impact, then perhaps you promote that change through to production as the default behavior. And if not, you can go back to the drawing board. But the main problem with that is that A/B tests are extremely time consuming to set up, and they can take multiple weeks to run. So we need a method to try and short circuit that process, to speed it up. And that's where offline evaluation comes in. Now, offline evaluation is just a way of simulating those changes in advance so that we can then filter out any changes that potentially have a bad impact before they get to an A/B test. But in order to do offline evaluation, we need something called judgments. Now, judgments are just a prediction of relevance. For this particular example, someone searching for mug, we've decided that only actual mugs are relevant. Anything with mug in the brand name is not a relevant thing. And that's very much a business decision. That's something that has to be agreed up front. But once you have those judgments, then you can start to build your offline evaluation system. And those systems are usually based on two key areas. The first is retrieval. Are you getting as many relevant products in front of your customers as possible? And the other is ranking. Are you pushing the more relevant products towards the top of your recall sets and the less relevant ones down? And when you've got those two areas, you've got the basis of an offline evaluation system. Now, historically, we've used two methods of creating those judgments. The first is often called explicit judgments. They are perceived relevance. So this is a kind of theoretical interpretation of relevance. And we get those from human judgments. These are generated by third-party companies that provide relevance judgments. Now, the second source of these is often called implicit feedback. This is actually what customers want. And this is measured through what they click on, what they add to their basket, what they actually end up buying. I said historically, so those two sources don't work in the same way that they used to. Recently, we've gone from having a very stable online catalogue focusing on groceries, and we've introduced two new verticals. We've introduced a marketplace offering, and we've also introduced online clothing brands as well. And with that, we've seen an order of magnitude increase in the number of products we have in our catalogue. And if we then try and predict forward, we anticipate that growing by another order of magnitude in the coming years. So all of a sudden, we've got a huge number more products that we have to provide judgments for. But it's not just the products. We also have a huge number of queries that we're having to evaluate. So when we look back over the last year, we had upwards of 30 million unique queries. And when you can combine that with the different number of products, that's quite a large space to perform offline evaluation against. And if we go back to our two sources, if we look at the human judgments, those don't scale very well anymore. They're slow to generate. They can often take of the order of days to get those judgments, which is obviously not ideal if you're having to generate new judgments quite quickly. And they're also incredibly expensive to get as well. When it comes to the implicit feedback, you've got slightly different problems. So with a lot of these kind of new products, we don't have any kind of implicit feedback. We have no interaction data, so you get a bit of a cold start problem. But we also have the issue that those products tend to be deemed less relevant and therefore don't get shown to customers and therefore don't ever get a chance to actually get any implicit feedback. So you end up with this presentation bias. Now, for the purpose of this talk, we're actually just going to focus on that perceived relevance. Whilst implicit feedback is incredibly important and probably the subject of another talk, we're going to focus down on those explicit judgments. And that's where judgment models come in. Where the human judgments are slow and expensive to create, judgment models can come in and provide a much faster and cheaper mechanism for scaling up your judgments. And maybe it's as easy as just sending off a prompt to an LLM and getting a judgment back, and then you've got your judgments. But as with all sources of judgments, you need something to measure the quality against. And that's where golden data set's important. You need a set of judgments that you can truly trust and use that as a benchmark for any kind of judgment source. And we believe that a good golden data set has three key categories, three key properties. The first is it needs to be representative. It needs to represent the types of queries and recall sets that you see in your system. Above all, it needs to be high quality. These need to be truly trusted judgments. And then the final thing it needs to be is it needs to have sufficient coverage. So it needs to have a large enough data set that when you do the analysis of your judgment quality, you can be accurate in terms of the statistics that guide you. Now, the way we went about trying to curate that golden data set is we started with all the queries that we have in our system in a year. And then we filtered it down based on search volume to get to a subset of that, which we will then use for offline evaluation. And from there, we were able to do a random sample of a few thousand queries. And that was the ones that we'd use for our expert judgments. But once you've got your queries, then you need the products. And for us, that meant getting actual valid recall sets. You don't just want to randomly sample from your product catalog, because you'll end up with a huge number of products that are completely irrelevant to a query. So for us, we used a mixture of keyword search, lexical retrieval sets, and also semantic to get to a sensible recall set for each of our queries. And once you've got that, then you can start to compare the performance of your judgment models. It's just as simple as comparing the judgments your model creates versus the golden data set, seeing where they agree and they disagree, and you can then get a sensible error rate, which you can use as a metric.
Now that we have a way to actually evaluate our judgment models, we can begin making the models themselves. And with this come various design choices. And these not only impact the performance of your model, but they'll also impact the potential use cases that it can be applied to. So to just give some examples, there's the choice between a sort of off-the-shelf model, which you can just immediately throw at a problem, versus a model that you might want to fine-tune on some data set beforehand. There's going for a large model versus a small model. So these will affect things like overall performance, but also the speed with which you can run inference. And then there's also the option of having a proprietary model, which again, you can kind of just use out the box and is already hosted for you, versus using something open source that you might need to sort of build the infrastructure around yourself. And this is a non-exhaustive list, just some examples. So for our first version, we wanted to go with something that we could use and sort of use as a proof of concept as quickly as possible. And so we go for an off-the-shelf proprietary large model. And so we just pass it a prompt in this case, and we're just using binary relevance judgments here. So 1 for relevant and 0 for irrelevant. And so we'll give an example of a query product pair, ask for the label, and in this case, we get relevant out. And while I say this is an off-the-shelf model, there is still some degree of tuning that we wanted to carry out. So specifically, we evaluate our models here, typically using confusion matrices. So this is characterizing the rate at which you get different types of labels wrong. So along each x-axis, we have a sum to 100%. So we can see here our model is typically getting 64% of irrelevant labels in the dataset correct, and it's getting 87.6% of relevant labels correct. And then to get like a single number to this, we're typically using the macro F1 score. And so we tune our models in this situation by tuning the decision threshold at which we consider something to be irrelevant or relevant. So the threshold that we're applying here is on this continuous score, which we get by applying a softmax to the log probabilities of the 0 and 1 labels. And we just pick whichever threshold ends up maximizing the macro F1 score on our training data set. And then we evaluate to give us this test set performance on the left. And so having done this, we actually find that we are able to already use this model in offline evaluation. And so the example I give here is a real world example that we actually had when running offline evaluation over a very large query set, and it was able to help us identify a query that had improved between two variants. So the query in this case was deep fat fryer. And so our variant 1 is returning a set of products where you can see there's a problem in the system returning air fryers instead. And in variant 2, we get a much better recall set. And so these were the judgments generated by the model, and we were able to immediately identify this query out of the larger query set we're evaluating on as being something that had improved, but with variant 2. It's worth noting the cost and complexity that come with this particular approach. So because we're calling a proprietary batch API, we are typically spending some cost as a function of the number of input tokens we're providing. It's also a batch API, so there's typically some latency involved with submitting like a labeling job to the queue and waiting for it to go through. And there's also the architectural complexity of having to maintain a central judgment store where we have to make sure it's sort of in sync with the existing product catalog so that we aren't penalizing retrieval systems for retrieving things that are sort of no longer in the catalog but are still in our judgment set. And the other key issue here is that we struggle with more complex classification. So on the left, we have this the test set binary labeling performance, which I showed earlier, again with this macro F1 of around 0.7. And we have business stakeholders potentially requesting if we can give 3-tier labels instead. So you'd have irrelevant, low relevance, and then high relevance. And this might be more useful for, say, NDCG calculations. And you can see here the model in this case, even when fine-tuned, begins to sort of perform, you get like leakage of this slightly relevant label, which it struggles with. And so you end up blurring the boundaries. And so this is a case where the model struggles with a new requirement that we might have. And so given these initial observations, we then have a revised judgment model approach that we wanted to try. So this is version 2, which we've chosen to refer to as Tesco BERT. And so in this case, we're going for an open source, small and fine-tuned model. And we're having it perform 3-tier judgments. So in this case, it's a standard cross-encoder approach. We pass the sort of input query with some separator token and then the product in question. And then we just take whatever the highest probability class is output by the model. So in this case, we would go for highly relevant or 3. And so these models, unlike the version 1, do require a much greater degree of fine-tuning. So we have some high-quality judgment store of crowdsourced human labels. We pre-process them for quality, and then we're splitting them into train validation test sets, and we're following a very sort of standard MLOps approach of training and hyperparameter tuning on the validation set, and then using the base BERT model of our choice. And we then test on some holdout data set. And so we find here that with this smaller model trained or fine-tuned on this data set, we are able to achieve superior performance in the 3-label categorization. And so here on the left, you can see this the version 1 model's performance with the reduced macro F1 score. While on the right, we can see with the Tesco BERT model and the fine-tuning, we are able to improve this macro F1 score again. And you see less struggling around this slightly relevant label. But it is worth noting that we do have quite a high false positive rate here on irrelevant labels being labeled as relevant. And so this kind of highlights the importance of not just taking these individual like macro F1 scores as a measure of performance, but actually breaking down your performance across different label types. Because this particular type of error here of false positives would mean that this model is sort of very useful to use when we're receiving query product pairs where we know they have a tendency to be relevant, such as things coming back from search retrieval systems, but we wouldn't want to try labeling an entire product catalog for a query in this case if it's a very large catalog, because we get a lot of false positives out of that. So sort of really understanding this entire confusion matrix is important to understanding the potential use cases with this model. So to give another example of how this does impact our use cases, we can compare offline evaluation, offline judgment generation to online judgment generation. So in the case of the version 1 model, the way it's currently deployed is we have our offline evaluation system. It will get some query set from a set of candidate queries. It will get the results for those queries from our search system for a particular config, and it will get the judgments from our judgment store. And then you have running asynchronously your labeling pipeline, where we again get the queries that we want to maintain labels for. We generate candidates from the system for those using a mixture of BM25 and hybrid retrieval. And then we can send them to our model for generating judgments, and they get added to the judgment store. And this is asynchronous from the offline evaluation process. Whereas with the online judgment generation, we can just retrieve the queries from the candidate query set again, generate the results for them from a particular config in the search system, and we can immediately generate those judgments on the fly because this is a smaller model that we can host and we can run inference on very quickly. And so we don't have to worry about maintaining this asynchronous process where we're maintaining a centralized judgment store and keeping it up to date. And at this point, it becomes less about maintaining some central store of judgments and more about just maintaining a particular model version. So you can reproduce your results by just knowing which judgment model you used to generate your judgments. The one caveat here being that while you don't have to maintain a ground truth dataset anymore, you can no longer calculate recall as reliably because you aren't labeling the entire dataset. So you don't know what the false negatives were. And you also can't calculate your global IDCG. So this is the denominator in your NDCG calculation, because again, this requires a knowledge of false negatives. That would require labeling the entire product catalog, which is not possible with this particular model implementation.
So those were the first two iterations we've tried, and we can continue to try and improve, and we plan to try and improve and solve some of those problems. But we need to know when enough is enough. When do we think we're going to start to see diminishing returns in improving these models? And that's where we have to set ourselves a goal. And for us, that's just about having a judgment model that's at least as good as the human judgments we've had in the past. Those human judgments don't scale well. So if we can achieve the same level of accuracy, but with the scalability, then that's obviously a positive position to be in. And for that, we need to compare to the expert judgments, the golden data set that we've curated. And the criteria there is just that if we take the absolute difference of our judgment models and the golden data set and compare it to the absolute difference between the human judgments and the golden data set, then we'll be able to measure the performance difference. And when I say absolute difference, that's actually the size of the difference as well as the number. So if you've got binary judgments, that difference would be 1 versus 0. But if you've got a multi-category relevance system, then you can have a much bigger absolute difference per judgment. A couple of the areas that we're looking to improve. So one is to look at hyperparameter tuning. And what we've seen there is that we have a bit of an issue with sort of overly optimistic judgment relevancy. And so for that, we think we can start to adapt the loss functions, perhaps to penalize where irrelevant products are being deemed relevant. And the other area is looking at training on hard examples. Now, this is not easy to do. Trying to find hard examples is a non-trivial activity, but we think we can actually use active learning to do this. And where the model itself is identifying where it's unsure, we can use those as hard examples to train the model on. A couple of the key metrics that we use in measuring search are recall and NDCG. And both of these are affected by the model's tendency towards overestimating relevancy. In the case of recall, you're trying to measure the number of true positives out of all the relevant products in your catalog. And with NDCG, it's calculated where if you've got a set of relevant products and then you've got your recall set, you would weight the relevant products by their rank, and that's your DCG score. But then you have to normalize by the idealized ranking. So in this case, all those relevant products would be pushed towards the top, and that would be your idealized ranking. But that's just on a local basis. So if you want to measure NDCG at a global level, you need to know about all the relevant products. So in this case, there's another relevant product in your corpus, and that global NDCG is normalized by having all those relevant products in there. And this is where the challenge comes in, because in both these cases, that requires you labeling the whole catalog. And when you've got an overly optimistic model, then it's going to push the number of relevant products that it thinks exist to a much higher number and push down those metrics. Now, we started off by saying that improving search is incremental, but improving our judgment models is also incremental. We started off with our human judgments, which didn't scale very well. And then we moved to an LLM-based system, which was able to scale much more easily, but unfortunately had accuracy issues, particularly when trying to perform more complex tasks. We then moved to a fine-tuning approach, which was able to handle those more complex labeling activities much more easily, but it still has issues in terms of the accuracy when labeling across the three categories. Now, for us, the goal is to get to a point where we've got a judgment model, which is both fast and cheap, but also has the level of accuracy that means that we can be really, really confident in our offline evaluation process. And with that, I just want to say thank you for listening, and we'll happily take any questions.